All right, so welcome to my presentation. It's titled Keeping Complexity at Bay, or You Aren't Gonna Need That Compiler. So, hello, my name is Joseph. I do Drupal. More on that later. So let's start with this meme about Drupal. So you've probably seen this meme several times already during the course of like doing Drupal. So somehow like Drupal is somehow like harder than the other CMSs. And I attribute that to like two things. So first is that Drupal is just a big framework that you just can't learn overnight. Like it's a CMS, it's a content management system, user management system, it's a permissions management system. It's a web application framework. It does ETL, it does like cron jobs and stuff. And it just happens to serve web pages. Like that's how I frame it. Like serving web pages is like just a small part of what it does. But the second is the way the way developers work on top of Drupal. So if you think about it, like you have Drupal like in the center, and then you lay like developers tend to like layer stuff on top of it, like build tools, processes, all that fun stuff that's specific to a project. So the first one, Drupal being a big framework, nothing we can do about that. That's just the nature of big frameworks. If you hop over to like other languages in their frameworks, it's just the same. So if you like hop over to Java, there's like Spring. In JavaScript, you have like React, you have Angular. So same deal. But the second, like how we work with Drupal, especially tooling, that thing we can change. Um, so a bit of backstory before we dive into like the main topic. So we have HTML, CSS, and JavaScript, like web technologies. So HTML, originally a document format. So if you take a web page and strip away all the JavaScript and CSS, it's like print, right? So it's like you have like headers, you have paragraphs, lists, block quotes, that sort of stuff. And then you have CSS, which was like meant to style set document formats. If you look at CSS2 and older, the styling properties are like floats that like text wrapping around images. You have columns, you have page breaks, margin collapses, and all that stuff. And then we have JavaScript, which was designed to like sprinkle a little bit of interactivity on those pages. Like fast forward 30 years since then, we now build apps using these same technologies. Many things were many things changed, many things were improved, added to the languages. Um, and that was like 30 years from when these were like initially introduced. But that's not where the fun is. The fun happened somewhere in the middle. So somewhere like 2010s. Developers tried to build the apps of today using the languages of yesterday. And it was limiting. There were limitations. Imagine doing layouts without Flexbox. Like we had to deal with floats back then. So developers are like, what if we could extend the languages of yesterday, build the apps of today, and then just compile it back to the languages of yesterday, right? So it was also the time, like 2010s was also the time Node.js came out. So it's like developers were now able to write their tooling in the same language as the language they write their apps in, so in JavaScript. So you didn't have like to hop over to C or Python or Ruby to build your tools. You know, just wrote JavaScript for everything. So now in the 2010s, there was an explosion of like build tooling. So we now have like build tools, we have minifiers, we have bundlers, we have new languages, module systems, package managers, so on and so forth. And at that time, though, it felt great. Um, but then we now have, like today, we now have a generation of developers thinking, or we now have a generation of developers and also convince the older developers that modern web development should now be done this way that you have to compile your code, to minify your code, to bundle your code, ship it with source maps in order to build something usable. But I don't think it wasn't that way back then. And I don't think we should continue down that road. Um, you don't need to compile your CSS in JavaScript. So back then we had this table, which told develop. So on the left, these were like language features, the new language features, and then on the center are like the main modern browsers. So back then, this table would be full of like yellows and reds because of like limited support in a specific browser or no support at all. But these days, most of the aside from like very edge casey like like new regular expression features, like the browsers have been keeping up. Same thing with CSS. So browsers today are like Firefox is like 145, Chrome is like 140, 141. Um, but as you can see, like these CSS features have been supported um, since the double digit days. So CSS variables, new functions, like new pseudo classes, nested syntax even is already in there. So, and then bonus, not necessarily like related to compiling, but we used to pull in JavaScript frameworks or like big JavaScript libraries to support things like dialogues, accordions, players, video players, audio players, um, custom form elements. But now HTML has them built in. So there's no, like, you don't need to pull in libraries. You don't really need to compile your JavaScript and CSS anymore. Um, you also don't need to minify your CSS and JavaScript. So for anyone who skipped the front end or ran away from it and went working to the back end because JavaScript and CSS was crazy, here's a refresher of what minification is. So minification is like reducing the size of your code without changing the logic. And this worked because we as humans write code for other humans, and today it's also LLMs. But we write code so that it could be understood by someone else. So we tend to write it like with good formatting, with very explicit variable names, identifiers, like so, so that someone else can read it and then maintain it. But the browser, like JavaScript engine, your HTML, your CSS, the browser doesn't really need very verbose code. So it can just variable names could just be like really short. And it would just like run the same way. So that's what minification takes advantage of. So we can have like really short code that only a machine can understand, but just like run it in the same way. And then we do minification to like reduce the asset sizes of code. That way we can make transmission more efficient. And minification reduces the code size by 15%. Could be more depending on how code was written. So here's a really simple example. You have like original code on the left, and then how it would have been minified on the right. So the way a minifier sees this is like, oh, this is a two-branch conditional. Okay, let's use a ternary instead. Oh, this conditional is only assigning a value to foo, so let's use that ternary as an expression that can be assigned to foo. And foo is only used once in this code. It's only used in console.log. So why not just inline it instead of assigning it to a variable? And that's how we end up with the code on the right. So here's a real-ish world example. So if you have worked with Drupal, there's whenever you do batch jobs, there's this progress bar that shows up, right? This is the JavaScript that powers it. Really small JavaScript, but still real JavaScript. So this is how it's written on the server side. And then on the right is a minified version of that same JavaScript. So from 1200 bytes, it's now down to like 400 bytes. and it would work the same way. So, but minification is not the only way to reduce assets served from a server. We also have server compression. So this works at the data level. So it doesn't care about the language of the thing it's trying to compress. It's just working with bytes. So same goal. It's to reduce the bandwidth usage, makes transmission more efficient. And then how it works is that when you serve assets from the server, it the server compresses that asset, sends it down the wire, and then the browser decompresses it. So it's your classic space and time trade-off, where space in this case it's bandwidth is the like is expensive, but your server and your smartphone are really powerful devices. So decompression and compression is fairly cheap. So that's the trade-off it's doing here. And it happens transparently. So your HTML, CSS, and JavaScript does not have to care that it was compressed. Your server, maybe like depending like how you do your compression there, it may or may not care how it does the compression. But compression reduces the sizes of assets by 80%. So you like yeah, 80% or more. So here's an example of compression. So say you have JavaScript. And you see like there's very repetitive parts here. So the way a compressor would work, or yeah, a compressor, um, is it would look for repetitions and put them in a dictionary. So imagine the dictionary being like a key value pair structure. So it would find function, store that in dictionary, find this yellow part here, put that as the second item. And then the third part would be this closing teal portion. It would put that as the third item. And then taking that dictionary and the original item, it will generate the compressed version of that data. So it would replace the function green with an asterisk. So it doesn't actually happen like this. It's just a visual representation. But as you can see, like the compressed version is now shorter because it removed like repetitions. And what gets transmitted down the line is the compressed version and the dictionary. So from the server down the line, and then the browser takes the compressed version of the data and the dictionary and decompresses it back to the original. So here's an example. This is from an article from CSS Tricks 10 years ago, like 2015. So they took Bootstrap 3, like the full CSS, and tried to do a combination of minification and compression. So as you can see, just minified is just 123 kilobytes, so 15-ish, 17-ish percent reduction. But then if we just do gzip, it's now 22 kilobytes. And then if you do both, you save another like 2 kilobytes. So if I showed you this and made you choose like which one would you rather choose? Would you rather wrestle with hundreds or gigabytes worth of like build tooling, change your workflow when you develop, change your deployment process for very little gain like size reduction via minification, or would you rather like flip a switch on the server, enable compression, and then call it a day, write your CSS normally, and you'd get like 80% reduction, right? So what does this mean for Drupal? So up until now, like it's all front-end technologies. I haven't mentioned anything about Drupal. But the nice thing is that like Drupal does many of these things for you already. So it starts with on-the-fly compression. So this is not specific to Drupal, but it's related to Drupal. Specifically, this is this on the server where you normally host Drupal. So all you need to do is make sure compression is enabled on the server. If I remember correctly, Nginx, you just need to turn on gzip. There's probably something related to IIS. But in the case of Apache, all you need to do is make sure mod deflate is installed on your server and enabled. And then the way you verify this is when you make a request on the server, like let's say you open a web page using your browser, when you look at the DevTools, first you need to check if the browser is sending the correct header, so accept encoding. So this means the browser accepts gzip, deflate, Brotli, and zstandard in this example. And then what the server will do when it receives that request, it will choose, if it supports compression, it will choose one of those. In this example, server chose gzip because it can do gzip. So browser requests for asset, server responds with whatever it can support. Another way to check is to compare the transferred size and the actual size of the asset. So in this example, this web page is from uh, Umami, like the Umami demo page. So the original like home page is like 60 kilobytes, but what got transferred is just 13.8 kilobytes. So that means it was compressed down the line. So only 13 kilobytes went down the wire when the actual size of the page was 60. And not all assets are equally compressible. So if you notice, CSS, really highly compressible. You have jQuery from 78 to 28. But then down here, you notice fonts are not compressible. The size remains the same. So images, videos, audio, font, and some other assets are usually not compressible because they're already compressed. If you compressed already compressed assets, they will just grow. So you'll need to tell your server to like skip those. Whereas HTML, CSS, JavaScript, which are essentially just text files, they compress really well. So asset management, also known as libraries. So you've probably seen this a whole bunch of times whenever you forget how to add CSS and JavaScript in Drupal. So, and this is like a really powerful feature of Drupal. So this is how you would register CSS and JavaScript into Drupal. So if you have a module, let's say your module creates a block and you need to introduce like CSS and JavaScript, this is how you would register those CSS and JavaScript so that Drupal knows like these files exist. This also works as a loading order mechanism. So under the CSS property, there are actually like 5 categories. So there's base, layout, component, state, and theme. CSS loaded under those will be loaded in that same order. So base will be loaded first, then layout, then component CSS, and then state CSS, and then theme CSS. And there's also like dependencies. So if like a library depends on another library, you just declare the dependency, and that dependency will load before the one that's depending on it. So in this case, for JS, we have like cuddly slider JS depends on jQuery. So this means like jQuery gets loaded first before cuddly slider. So this feature alone, like this alone, essentially is like CSS layers, and then it's also like Sass imports. It's also like ES modules, so load order and the order which they're defined. So you may not need to do layering or module imports when you have this mechanism. Um, but the power of like the libraries system is actually in the aggregation. So if you look, so again, Drupal being this like big system has many modules in core. You probably use a lot of like contrib modules as well, and you probably also have your own modules. If you load the CSS and JavaScript from those modules as is, you'd end up with hundreds of CSS and JavaScript requests. So in this case, this is like the Umami page. The homepage alone loads assets in like 158 requests if you leave it be, like just as is, like load the file as is. But Drupal has this tick toggle, which everyone has probably turned off at some point because of like like debugging JavaScript and CSS not working the right way. But you should keep this enabled during in production. So what this does is take the libraries from like the earlier, like the YAML earlier. Drupal will figure out like the correct load order, And it will also figure out which files can be grouped together. So, and the reason Drupal does this is because like back in the day, HTTP 1.1, yeah, 1.1, the browser had a 6 connection limit for each domain for the entire browser. So that means if your browser, so for like, let's say you load a web page and one of those connections stalled, like let's say there was like a really huge asset or the connection broke at some point, everything that was loaded behind that asset that got stuck or caused the connection to break will not be loaded, and then your browser will feel slow and maybe the page won't load. So the optimization was to like bundle assets. So JavaScript was bundled, CSS was bundled, images were usually like put into sprites, like especially like icons. Um, Drupal does bundling. So for the same 158 requests, if you enable aggregation, um, you now have bundled CSS and JavaScript. So in this case, CSS is now like just 2 files, probably like core and probably like contrib modules. Same with the JavaScript, you have 2 files. One is probably from core, one probably from a contrib. Um, Now we're down to 34 instead of like 157 requests. And then Drupal takes this further. So the aggregation, so if you look at the config that where the aggregation toggle is stored, those are like the pre-process. So this is like the pre-process true, but there's a hidden property that does not have like a UI equivalent. It's this one, it's gzip, and it's enabled by default. So in addition to bundling, what Drupal does is also pre-compress the bundles. So in this example here, we have a example of a bundle. So here's all the JavaScript put into one file. But if you notice, there's also a version of it that has the .gzip, .gz at the end. So with the help of an htaccess file, once a browser that supports decompression requests for a bundle, and the bundle has a pre-compressed version of that bundle, the server will serve the pre-compressed bundle instead. So it saves your server from doing compression on the fly. So it's using the pre-compressed version. It serves it as is. Minification. So we talked about like earlier, like why like we don't really need minification, but if we need minification, then Drupal does a bit of minification for you. So there's work in Drupal 10.1 where they introduced uh, a PHP library. So it's written in PHP that parses JavaScript and then takes out um, comments, white space, and optional braces. So that's all it's doing for now. But that kind of library is the same kind of library that's actually used in JavaScript tooling, especially the ones that do bundling and minification. So what that library is usually used for is it parses JavaScript into a tree, and then how minification works under the hood is that it looks at that tree and removes bits that are unneeded, dead code. It renames variables and so on and so forth. It makes modifications to that tree and then regenerates JavaScript using that modified tree. So that's how you end up with minified JavaScript. So there's nothing preventing us from actually doing the same exact thing, but in PHP, in backend Drupal, all without additional tooling. And then there was similar work for CSS, but there's no activity. But the architecture is there. So and right now, what Drupal's doing is really just like manually parsing CSS like a string and removing white space and stuff. So bonus round, asset packages. So while we're in the business of like eliminating front-end tooling, uh, why not remove the package manager that also like brings in that tooling? So asset packages, what this is a repository for Composer that lets you download JavaScript and CSS libraries using Composer. So what it is under the hood is that it's a repository that is a proxy to NPM and Bower. Bower being like just a bunch of GitHub repos. So you do Composer require NPM asset or Bower asset and then library name. The library name being the name of the package in Bower and NPM. And it would download those libraries, and you just configure Composer to download these assets in web/libraries where we usually expect Drupal libraries to be put in. And then you just like Composer requires normal, and the packages will be tracked in composer.json. Um, so you don't need NPM anymore, you don't need Bower, you don't need Yarn. You can just use this and just have Composer be the one package manager for your project. So conclusion, Drupal can do no build. So as you can see, like a lot of things um, can be done with your typical Drupal setup. So as you just saw, like you can do management using Composer for front-end libraries. Like Drupal can do minification, do bundling, load order, essentially dependency management. It can do like compression in the servers. You don't need minification. It also So no build enables a simpler Drupal. So you have fewer tooling, so fewer things to worry about, fewer things to like download and install, fewer things to like work with when you're doing Drupal, fewer things to like do to worry about when you deploy, fewer things to worry about in terms of security. So fewer like dependencies mean fewer things to get snagged by your security scanner once you implement that in your project. And a simpler Drupal just enables everyone to do Drupal. So simpler Drupal means like anyone can just hop into your project. If they learn Drupal through like tutorials, online videos, um, courses, most like if you keep Drupal at that same level, then anyone can just like hop in, like new hires, junior devs, your QA, your PM, even your CEO can work on your Drupal project. And in the same way, like once they hop onto their like next adventure, maybe go to another project or a new company altogether, they can carry that same knowledge with them because it's just Drupal, like nothing specific. In contrast, let's say you have this really complex project with like really I don't know what's the term, unique way of doing Drupal. Like someone would have to like spend weeks or months just to like learn the thing and then agonize for years working with that thing. And then once they leave the company, it's like they carry nothing with them because like all their Drupal knowledge was like specific to that Drupal project, which they cannot use in their next adventure. But it depends. If you have like a really specific requirement, like let's say you had like headless Drupal with React, like React cannot live without its build tooling, so you're kind of stuck there. Like you will have NPM and your build tools. Um, but if you're just starting off with Drupal, if you're just learning Drupal or like managing a small site, it's just mostly content, stuff like that. You don't need a really complex Drupal setup. You can just like set up Drupal like you'd see in like tutorials and stuff, just basic and work off of that. And it's just fine. Like nothing's wrong. And that's the end. So I'm Joseph, as mentioned earlier. I'm a developer for Portland WebWorks in Maine. Um, I primarily do JavaScript, so my main language is JavaScript, but then Drupal pays the bills. So I lead Drupal teams, architect Drupal sites, mentor people to doing Drupal. And then once in a while, I get pulled into like Spring and React projects, so Java, TypeScript, JavaScript. If you want to reach out, Here's a link to a Drupal.org form that I've never seen before, but Drupal.org says it's there. So here's the link, and here's also the QR code. That's the end of the presentation. Thank you very much, and see you next time.